Yeah, I'm thinking we're just going to do a small quiz on this section before we start getting ready for exams, just to kind of, just a touch base, make sure we got it, and hopefully. Well, it'd go in summative, but it'd be less points than like a test, so it'd be smaller. All right, so, and then summatives you can retake. So, so if it doesn't go well, you have that option. All right. So we're gonna talk just about radians, and the reason why I wanted to talk about radians, part of why I wanted to talk about is because next week we're taking an exam and we're using radians on parts of those exams, and so kind of just trying to dust off the cobwebs a little bit about radian measure, and so you aren't feeling like you haven't seen it for a while, because you haven't, but now we'll review a little bit. All right, so yes, Jolie.
So, how we not use our note sheet on that one test with the circle?
No, you'd be able to, and then on the exam it'll be open for that.
So we can use our circle.
Mm-hmm. Yeah.
And
Wait, where do we get the circle? All of our note sheets?
Yeah, I'll give you guys. Yeah, that's why I keep them. So I'll give you guys all your note sheet back so you can kind of organize your information and put them all.
But you have to put like something you don't like. So she gives you all your notes.
Oh my god.
We have to kind of consolidate.
Wait, when are we getting our circles?
Your circles?
What circles are we talking about?
They're talking about the circles that when we had to put all those radian and degree measures on
Oh,
it.
for that one test.
Yeah. And she was asking, am I taking your note card away for part of the exam? And I'm not. So you can put that circle thing on the exam. All right. So, okay guys. So for graphing and polar coordinates, same idea where this is my R and then this is my theta. So again, you start at your 0. That's like our default spot, and we're going 2 pi over 3. Nicely, this is labeled for you, 2 pi over 3, and we'd be going out 3. So in this case, we'd just be there. So don't be worried about, again, switching back over to radians, just remembering that those are just another way to write this measure, just like, feet to meters or whatever, it's just a conversion. Then 3.5, and then 13 pi over 12. Now, if you notice, they tell us pi's over 6s and pi over 3, so pi over 12 is going to be half of pi over 6. So 13 pi over 12, if it's helpful, it might be worth thinking about this as 1 pi, or 1 and 1 pi over 12, because it's like 1 more than a full 12 pi over 12. That makes sense? For sure. So 3.5 is in between 3 and 4. But then, where am I going to be? So I'm going up past here, right? This would be 12 pi over 12. So we're going to be right about there. All right. So the next thing we're going to talk about is distance formula. We learned distance formula for regular coordinates. I just want to make sure you guys are aware that distance formula does not work the same.
John, stop.
We getting morning workout, John?
Get it together.
Carter was distracting me. Me?
Hey, yo.
You went with Carter?
Oh, you think so?
John, I think you need to stop lying.
John, first this morning workout, and now you can't pay attention in class.
You need to stop rolling.
Now I got out of your desk to talk to me. I thought you slept that extra hour.
Yeah.
Pay attention
But
in
it-
class.
Trouble for talking. Yeah, you're in trouble for talking. That's this. Oh, so it's really bad.
Oh! Burn.
Burn them, babe.
Yeah, you just got burned. Go outside and roast
Eat
some
some water.
And soil.
Come on, Bruce. What?
And fried.
Geez, I thought someone was easy.
Oh.
Okay.
Jeez.
We'll get it.
Oh,
polar distance formula, I wanted to write it up there just so you guys remember what I was talking about with this. So if I asked you guys to find the distance between 2 points, if they're rectangular, you would do this regular distance formula that you learned way back in probably like pre-algebra or something like that. Polar distance formula is a different formula. So you cannot, if we're talking about polar coordinates, we can't use that formula. So I want to make sure you're clear that that formula only works when it's rectangular, normal x's and y's. Which kind of makes sense because understand that this point is not x comma y, it's r comma theta. So just like we had x2, y2, you know, x1 or y1, you know, all those different pieces, we're gonna have the same thing here. So we have our points. So we have r1 and then theta 1. And then r2, theta 2.
What does a P stand for?
That's points. Don't you remember you giggled at me yesterday when I said points? Or not, oh, no, it was P. You giggled at P.
Point P.
Yeah, point P, and she giggled. Yes. I think that was her anyway.
Yeah, it was.
Okay.
It was definitely us.
You're so serious.
All right. Okay, so this is where this formula gets a little bit weird because it looks like I do have a subscript and I have a superscript. So there's a lot going on here. This is saying r1 squared and then r2 squared. They're talking about these first half of our polar coordinates is the r part of it.
These are whack. Oh.
So time to coach.
Yeah.
Why is it?
So it's 2 times r1, r2 cosine of theta 1 or theta 2 minus theta 1.
That's intense.
This is times cosine. What's that? That little dot down there is like a straggler. I don't know if that's what that one was bothering
Is
you.
there not a simpler, smaller equation?
No. So polar distances are definitely tougher than regular, but at the same time, when you first learned this one, you didn't like that much either. But at the same time, this is a matter of just kind of plugging things in and making it work. So they're giving us r1 and theta 1. Oh, I have the eraser on still.
What? Are you okay?
68.
You okay?
Do we type that all into calculator?
I did.
Did it work?
What'd you get?
I don't
What's the
know.
answer?
I don't know.
Man.
Okay. We're gonna put out, yeah, we'll try putting all this in. Now, if we're using degrees, your calculator should be in degree mode. If we're using radians, your calculator should be in radian mode. Right now we're in degrees, so you should be in degree mode, so hopefully,
What is the answer?
I don't know off the top of my head.
John,
Well,
calm
actually,
down.
Yeah, I don't have it in front of me.
I got the answer, I just don't know if it's right.
What'd you
Okay,
get?
we'll check it.
I'm gonna eat.
Oh, 8.29. I got 68.8. Yeah, I think that's. Should I get guys? Thank you.
Hey, John, you thirsty?
Being that there's more multiplication than
John.
it should be higher.
I did what she told me.
Use parentheses.
What's the 8?
Job.
8.2955. Yeah,
Get
ready?
I got 8.29.
Oh!
Dog.
Can I see your form? Oh, what did I just do? Oh, I didn't square root it.
Yeah, so you got like 68.8, John? Do you have like 68.8?
Yeah, I just forgot to square it.
Okay, yeah, so, and that's not actually the worst thing to do maybe, is like writing this all out.
I got 8.295. You're right.
Okay, one of other thing, guys, with this though, this is a time that if you actually, I don't do much rounding off throughout this problem. So I took the square root of the answer in this case, so I end up with like 8.3 as my distance feature.
Precisely what I got.
You're spoiled.
I know.
Oh, reading.
I'm a genius.
And now, so this one is the distance between those in terms of polar coordinates. So that's how far you would travel between those two. Now, where we switch that up is when we have to switch to radians. So this may require that you have to switch it into radians in your calculator. And if you don't know how to do that, I can always show you that. Most of you guys, if you have a graphic calculator, it's in the mode feature. If you have a regular like scientific calculator, it probably says like DRG on it somewhere maybe.
TRG.
And we want to switch to radians. So on like the bottom of your screen, it should say rad. You're in a good mode. Rad. And so you might have to switch in mode. It might be in the mode button. You guys find it?
Here.
Okay. Now, be careful with, we want to be in radians. Because now we're talking about radians, those are no longer degrees. Now be careful with the negatives though. When we square negatives, they become positive.
Can I just like get rid of that negative then right there to make it positive?
In the one case you can, but the other case you can't.
What do you mean? What other case?
When you multiply it later on times the 2,
Oh yeah. Got that one. Oh, wait.
Oh, you're definitely there. That's
now, one of the things I noticed was
I got one.
pi over 6 minus 7 pi over 6 should be like a negative 1 pi over 6 or negative pi. So that might be worth being aware of, like as you're going through this, that you're trying to. Yeah, I got one as well.
Oh my god, me too. Would you look at that?
Is the square root of 1 really 1?
Yeah. All right. And so if you're having troubles, I mean, this is really a matter of like getting this all into your calculator correctly. I would suggest kind of going in pieces, trying putting it all together, trying to like kind of monkey around with it a little bit to make it work. Monkey around. Yes. All right. I do want to talk about converting polar coordinates to rectangular when we're talking about radians. So talking about what that would be then as, so we're going from the r theta to xy. And so if you guys want to like take out your notes from yesterday on that, we have our rules on how to do that conversion there. And that has to do with finding, is that the tangent one or is it the other one? It's the other one, right? So this is the r cosine and the r sine, right?
Yep.
Yeah.
Yep.
So remembering that it's r cosine of theta and then r sine of theta. But again, when you guys do this, remember, since they're talking about radian measure, we have to be in radian mode. If you're not in radian, you're going to get kind of some crazy answer here. Radian mode. Now, if you love your special right triangles, you can also do this like kind of by hand, or think about what it looks like by hand as well. Because cosine of pi over 3 is actually kind of a nice number. So, yeah. Because pi over 3 is actually a 60-degree angle. What's that?
I was just gonna ask, how come you can't just convert the thing or the gradient to?
You could. Yeah. That'd be fine. It's up to you. I mean, you can just put this in your calculator the way it is too, so it's up. I mean, it's kind of whatever your comfort level is. So this one's going to be a little bit of an icky decimal. But again, it could be 2.5 comma and then 2.5 square roots of 3, because this is a special right triangle. So either answer, probably more likely to put that one.
How do you switch your calculator again? I don't have a
In the
calculator.
mode, oh, yeah, it depends on your calculator. So, like my calculator, I just hit this top button, this one you have to hit. So we just have to make sure you bring your calculator and we practice that.
Did I do it right?
All right. What's that?
Don't give up.
Oh, okay, so yeah.
Don't stop. Believe me.
All right. So this one, just so that you guys are aware of it, in this case, talking about our quadrants, we would be down pi over 6 over here, but we'd be going -1. So technically, we'd be up in the second quadrant. And so just kind of being aware of that as I'm doing these to make sure my answers like make some sort of sense. So I get a -0.87. And then I got 1/2 or 0.5.
Did you get it?
I kind of forgot the rest of the year, so I think I put 2021 at all my papers.
Absolute.
You're gonna be invalid. They're gonna think you're copying from someone last year.
That's the last, John. That's the last.
John.
That's the last.
What's